Okay, ladies and gentlemen, if you'll take out your lesson plans for your 3.1 material in Math 1033, you'll see the first question that we're asked. Is x equals 1 a solution of that equation? Now, of course, the way you can see this was approached, if I move my cursor to the very first line of our work, if you want to know if a number is a solution to an equation, what you're going to do is you're going to plug it in. So every place you see an x, we've replaced it with the number 1. And then we do the arithmetic. So of course 4 minus 1 is 3, 1 plus 1 is 2. Negative 1/3 times 3, which is really 3 over 1. The 3's cancel, leaving me with negative 1. 4/5 is what this becomes because of course there's no cancellation. 2/5 times 2 over 1 becomes 4/5. When I take negative 1 and I add 4/5 to it, I do get negative 1/5. And if you want to see the work, if you come over here, negative 1 was written as negative 5 over 5, getting a common denominator to add fractions. Negative 5 over 5 plus 4 over 5 equals negative 1/5. So the reason the answer is yes is that the number 1 is a solution to this equation is because it works, meaning it makes the left-hand side of the equation equal the right-hand side. So if someone simply asks you a question, is a number a solution, you just plug it in. Now these next couple questions are a little bit more realistic. Normally someone doesn't say, is this an answer? They ask you to find all answers by giving you the directions solve. So if I give you the equation 2x minus 5 equals 6 minus 5 halves x, what I recommend to my students, anytime an equation involves fractions, I find the least common denominator, which is what I mean by LCD, and that's the number 2, and I multiply through by the LCD. So putting these parens around the entire equation is my way of saying multiply every term by 2. So this becomes 4x minus 10 equals 12 minus 5x. So in other words, we cleared fractions. What I did to get down to the next line is we moved some things around. We got our variables on the left and our numbers on the right. So what we did is we added 10 to both sides and we added 5x to both sides, which gave us 9x equals 22. Therefore, x is equal to 22 over 9. And just because that's a mixed number, just because that's an improper fraction, you don't need to change it into a mixed number. It's in lowest term, so we're fine. The next equation, 3 minus 4x over 5 equals 3x minus 1 over 2. One way to approach this again, to clear fractions, is to find the LCD. The LCD of the two denominators is 10. So when I multiply through by 10, notice on the left-hand side, 5 will cancel into the 10 twice. 2 times the quantity 3 minus 4x becomes 6 minus 8x. On the other side, when I multiply by 10, 2 cancels into the 10 5 times. When I distribute the 5, I get 15x minus 5. I take my variables to the left and my numbers to the right, which leaves me with negative 23x equals negative 11. When I divide through by a negative 23, a negative divided by a negative becomes a positive, and I'm left with the answer 11 over 23. And this equation, some of my students actually leave the decimals in it and work with the decimals, which of course is perfectly fine because you're allowed to have a calculator on your test and final exam. So decimals certainly aren't forbidden. I personally like to get rid of the decimals. And what I've done here is I've multiplied, or I'm going to multiply everything through by 10. The way I determined 10 is I looked at the greatest number of places I had behind the decimal, which was 1. So that means if I move the decimal over one place, I'm virtually creating whole numbers. So when I multiply by 10, I get 25x minus 54 equals a negative 4 plus 15x. I then I reorganize the equation where my variables are on the left, my numbers are on the right. So by filling in the steps there, you see 10x is equal to 50. When I divide by 10, I end up getting x is equal to 5. All right, this equation, basically we're going to start off with a lot of distributing, so follow me through here. When I distribute the 4, I end up getting 4y plus 4. Now this next step is very important. You see a minus in front of those parens. That minus is letting you know that there's actually a negative 1 there that needs to be distributed. So negative 1 times 3 gives me negative 3. Negative 1 times a negative 5y is a positive 5y. Biggest place to watch out in this problem is right there with that plus 5y. On the right hand side, when I distribute the negative 2, I get negative 2y plus 4. On the next line down, what I did is I collected like terms. 4y plus 5y was 9y. 4 minus 3 was 1. So 9y plus 1 is equal to negative 2y plus 4. We then get our variables on the left and our numbers on the right by adding 2y and by subtracting 1. My final step is division, and this is how I get the answer 3 over 11. One last comment I want to make here, but I will make it again in the next video, is anytime any of these equations that we've looked at today are sometimes referred to as conditionals, and they will ask you this in your Course Compass homework. Conditional is an equation that has a finite number of answers, in this case, one answer. Okay? So when you get an answer to a problem like x equals 3 over 11, x equals 5, y equals 15, that equation is referred to as a conditional because it means there's a condition that exists that makes the left-hand side equal to the right-hand side. Okay, I'll be continuing with 3.1 with other videos, but this is going to be the end of the part 1 video.